Thank you for the introduction. So my name is Daniel Cahalarn. I'm the Director of Construction Solutions at Asset 55. The topic of this short presentation is called Failure to Finish, and why the last 25% of progress often takes up to 50% of the overall duration. Now, the projects in oil and gas, particularly mega projects, are challenging, they're highly complex. And if we think about the generic setup in the execute phase, we tend to go in an area or a bulk construction mode through 65%. And then we have a change of focus to try and deliver the mechanical completion sequence, system turnover to support commissioning. It's often in this transitional space, which we believe happens far too late, where operators are part of the inspection regime, that there's a realization that projects aren't potentially as far advanced as has been reported. And this creates a pressure cooker situation and often leads to reactions to try and chase, recapture progress that is missing. What this tends to then happen is the schedules start to move right. And it's in this moving right, it's not just a schedule delay, but it also creates safety quality type of issues. Often as we get near to completion, particularly in fabrication environments, there is a decision that's made that projects leave with outstanding work. And in a way, we could term this as failing to finish. Now, what all of this then leads to in an integration phase where we have a base scope that's quantified is we now have added complexity. The carryover and transition work manifest and add extra pressure in the integration phase, which again leads to extensions of time in integration. Now, one of the things that becomes very apparent here is there is a schedule impact and a cost impact. But one of the key pieces in late starting of the mechanical completion process and what happens in this pressure cooker is the effects of safety and quality. Now, safety gets impacted because we have a significantly increased volume of activities associated with stored energy, the hydro testing program, the energization of cables. This happens with peak manning on a project, but it also increases the extra working issues of barricades and exclusion zones, which manifest to increase the problems within this phase. So as an industry, we need to address this phase of a project which leads to poor completion outcomes, both in terms of an EPC perspective. In a lump sum environment, this is now time that potentially isn't being paid for. And from an operator's perspective, it impacts the startup and production sequence. So in order to do this, what we need to be focusing in on is not just the phase in which this problem appears to manifest, but it's about how can we start some of these activities that we normally focus on in the final third much earlier. And when we focus on these activities earlier, or we can unlock them, it leads to an earlier inspection regime. And what that inspection regime creates is a quality of build. It also creates some form of predictability as to where the schedule may be moving towards in the back end, and we don't have a knee-jerk reaction at that 65-70%. And where we need to be focused in here is the last 25% of projects shouldn't create this tail on the back end, and we can actually deliver these projects in 25% of the overall time. So what we need to do first is take a look at why some of these issues occur. And at the very beginning, it really comes down to a data foundation, particularly as we're focusing more in on digital project delivery. What we've seen across a number of major operators and EPCs which we have worked with, data standards are not very well prescribed. Requirements are not established. They're certainly not transposed across projects, creating a predictability or a consistency. The second thing we see is that engineering data often isn't validated. And whilst many EPCs have integrated tool suites, there are still data quality issues with manual processes. And if we don't have a data foundation that we can trust, it impacts our ability to start the activities that set the back end up for success. Things like developing our system and subsystem boundaries, the ability to create test packs early, or cable routing, which are actually the cornerstone of the ability to plan with the end in mind. If we don't have a solid data foundation, it means we can't optimally plan. And what often happens is this lack of validated data leads to distrust, and it erodes the perspective of what scientific approaches to planning can actually bring. When we don't fully understand or visualize commissioning sequence and not understand the priorities of the back end, we're left with only focusing on the path of construction. And whilst this gets us to probably that 65% piece that we looked at in bulk construction, it's not often conducive to how we need to complete projects at the back end. And one of the things that we see historically across projects is that the area to system trade-off from a planning perspective happens far too late. And when this happens far too late, the ability to change the course of action when you're already well into bulk construction is significantly reduced. The final piece in all of this is around controlling execution. And if we don't have data and optimal plans established, or the creation of a control environment, it means we lack visibility in terms of status of the project and workfront availability. When we don't have a real clear picture of status visibility, it leads to projects getting out of sequence, chasing progress to maintain KPIs, but which isn't actually conducive to how we need to complete and commission projects. For me personally, completions activities in a bulk perspective start way too late. We need to be focusing in on these far earlier than the traditional 65-70% complete. And what happens when we focus on this late, it creates this highly reactive, chaotic environment that actually leads to a decrease of quality of build and also increases safety quality issues. And what we also see is that we tend to still be in a construction mindset when we are commissioning. This creates that kind of pressured environment with, again, greater risks and creates a SimOps environment during the commissioning phase. So how can we change, or how do Asset 55 look to address this challenge? So we've created data specifications, data standards from having looked and evaluated probably 30 or 40 projects over the last 5 or 6 years. And it's to understand what do we need, when do we need it, why do we want it, what can we do with it? What are the formats this data needs to be received in, and what's the frequency? The second piece is through a software we've created called EVA. And it's about performing this data validation in terms of conformity to tagging standards or specifications, making sure the tags are consistent across sources and they're complete in terms of their attribution, and that the attribution across these sources is also consistent with each other. When we get that, we have very clear and early visibility on engineering maturity. But it creates these foundation blocks that we can now use from a digital perspective to apply any analytical or scientific planning. If we trust the data, then it's going to improve our confidence in how we plan and analyze, and it's going to allow us to address some of these early completion elements in terms of systemization, subsystemization, and test pack development. Once we've proven that we've got robust data, we can start to move into ensuring optimal planning. And the real key piece that the industry misses here is applying a scientific approach to path of construction versus path of completion, commissioning and startup. And the optimal way in which we need to look at this creates a trade-off between a construction and a commissioning groups, which allow us to create that optimal path of the project. One of the things we tend to focus on in bulk construction is about KPI tracking. How many quantities of different widget types do we need to execute? What we really need to be focusing in on which ones are most important. It's not just the quantities, but the right quantities. And we want to correlate these quantities to understand at what point, if we follow the plan, are we going to have test packs to walk down? Are we going to have cables to pull? Because this then creates the ability to start completions far earlier than we traditionally do in a completely predictable manner. In creating this predictability, we can understand potentially complexity trade-offs of systems that are very difficult to complete and why we may end up optimizing a sequence to support the back end. Once we've supported optimal planning, we use our construction solutions to really control, monitor, and influence project outcomes. It's the ability to see status information across all tags, disciplines, and understand their effect on each other in terms of completion transition. Inside of the system, we have a module that we call completions enablement or construction analytics. And largely what this is looking to do is understand the associations of tags. So it may be that an isometric sits on two service supports. When the service supports are installed, it will automatically tell us if those spools are in laydown that they can be installed. Or if there's a test pack with 10 spools and the final spool gets reported as being installed, it would automatically tell us that there is a test pack available for walk down. The ability to create this analytics across multiple different facets supports people going out to go and do the inspections, understand quality of install, and largely drive that completion process. So the key drivers here around complete status visibility, the ability to unlock that completion process far earlier and support commissioning and completions overlap to drive predictability at the back end of projects. So in summary, we need to first address these challenges and the causes around poor completion outcomes. And we really need to focus in on the last 25% can be delivered in 25% of the overall duration. If we focus in on three key areas, in the very front end of projects, we need to have data standards that create the ability for us to receive data in a timely fashion to drive some of these automation opportunities. The second piece, once the standards and the data is being received, we need to validate it. And it's in the validation that supports both EPCs and operators to have greater confidence with the downstream phases. In terms of planning, we need to change planning from really an artistic approach to a scientific, data-driven approach, where we can start to include path of completions and commissioning with path of construction to deliver optimal paths of projects. In order to do this, we need to leverage technology. And when we leverage technology, it's about really improving that visibility. It's about creating an environment where multiple project participants can communicate, collaborate, explore challenges, and agree on optimal paths forward for the project. And once we have a plan that we can trust, that is based on science and linked to data, and all of this then controlled in an execution environment, we can track the project on a daily basis. Complete status visibility, multi-phase, multidiscipline, all in real time or as near real time as possible, which gives us far greater understanding to the challenges, the risks and the opportunities, which improves our overall decision making. Technology is the cornerstone if we get the data right. And if we have solutions that create automation through analytics, that can not only identify the construction availability, but also that completions transition availability, it's going to support us to reduce the tail on projects, hopefully deliver the last 25% in less than 25% of the duration, and us all be part of successful projects. Thank you very much.
Thank you very much, Daniel. I like the way you got into data where other people probably have not, because I think there's different interpretations of what people feel about data, and I think that's an approach thing with different companies. So I think everyone thinks they know it, but at the same time, you've raised some very significant points about getting your house in order and getting your data house in order as well. Can I ask you, Daniel, can you share an example of data-driven planning which you feel is often overlooked? Because I have a couple, but I'd like to know your opinion.
Yeah, no problem. Thanks very much, Adam, for having me. So in the presentation, I took more of a linear approach, looking at kind of area to subsystem transition. But one of the things that often catches projects, particularly in that latter phases, are the activities that have associations across multiple subsystems that often have different priorities. So leak testing or nitrogen helium leak testing is a prime example. You need test packs to be reinstated. These test packs often cross different subsystem boundaries. Some may be associated with a high priority and some with a low. So if you only focus on a kind of a mechanical completion sequence, excuse me, these leak tests at the back end end up moving right. And on, say, an FPSO, you need 6 months to complete a leak testing program. And linearly following a mechanical completion sequence may mean you only end up with 3 months. And it's a key cause of these type of activities becoming carryover work or transition scope to the next phase.
Oh my God, that makes a big difference. And what in execution, because obviously you've got the execution part, which I feel is, for what you said, is very significant. What do you feel is the most important element to create, let's say, predictability in schedule outcomes?
Yeah, for me, opening completions activities early. I've spent my whole career as a planner, predominantly in EPCs, operators, often in that last 30%. And the chaos that ensues, the projects that we're evaluating and supporting at the moment, all have the same issues. Different EPCs, different project types, different operators, same issues. leak testing, heat tracing, insulation, EX inspection, these multifaceted pieces, and most of them start completions far too late. When opportunities exist, capitalizing on them drives a
Mm.
quality focus to workmanship, and in that reduces discovery work, creates predictability. So the greatest thing for me to change outcomes is capitalize on completions opportunities as early as possible.
Very wise words, Daniel. Thank you very much for this, and thank you for joining me.